unique name just for our class, so it's our own little thing. So for the generic videos here, I just want to put a cat in there. We have this cat that's being chased by a dog. They're running at 6 meters per second when they encounter a wall. The cat bounces off the wall and runs at 4 meters per second in the opposite direction. Okay. The cat's in contact with the wall for a very small amount of time, only 0.05 seconds. What is the magnitude of the average acceleration of the cat while in contact with the wall? Okay. So I want to know average acceleration. Okay, so I need A average. A average, I know, is the change in V over the change in T. And just like we had talked about in the first one, this is the two changes, TF minus TO, the two, or TI. I might do it as TO in class. This would be the two changes, VF, change of velocity over the change in time. It's always final minus initial. Okay. Now you might want to plug in some stuff, some numbers in here going, okay, in the end the cat was running at 4 meters per second, and in the beginning the cat was running at 6 meters per second. That is a common problem with students, is they just grab the number straight from the question and they plug it in without understanding the question. To better understand the question, we're going to draw lots of pictures. So let's draw a picture for this. Okay. There's my cat. Yeah, there's my dog. Doesn't really look like a dog at this point, but anyway. Dog's chasing the cat. Cat is running, let's say, at 6 meters per second this way. They encounter a wall. Okay, so this is the before. Cat bounces off the wall and runs 4 meters per second in the opposite direction. Okay, and there's our cat, running at 4 meters per second in the opposite direction. So you got to be careful when you plug these in, because velocities are vectors. Direction matters. Okay. All right, so let's start plugging in. We have A average, the final velocity. Okay, the final velocity of the cat, the way I drew it, is 4 meters per second, but it is in the negative x direction. I just as well could have wrote or drew the picture the other way, okay, and you'll still get the same answer. So it doesn't matter which way you draw the picture. But knowing the direction of travel is important, so one of these had to be negative. So I made the final velocity negative. Okay, so I'm going to have a negative 4 meters per second for the final velocity. The initial velocity was in the positive direction at 6 meters per second. So 6 meters per second. Okay. The time it was in contact with the wall, we don't have a T final, we don't have a T initial. Instead, it has told us what the change in T was. It's very, very small, 0.05 seconds. Okay. Now for an average velocity like this, we'll always get a number out, but we're going to go ahead and give an absolute value, because I could have easily have just drawn the picture the other way, in which case it would have been a positive number. Okay, so our average velocity would be a negative 4 minus 6, so it would be a negative 10. Absolute value of that would be 10 divided by 0.05. Okay, and if we do that out, 10 divided by 0.05, that's what we get. We get 200. Okay, this is an acceleration. This is meters per second, right? Velocity is in meters per second, time is in seconds, meters per second per second.